In this video, I'll discuss drawing stairs, and it's all in my book, Ellen's Guide to Drawing Shapes on Amazon. I'll briefly discuss inclined planes, which are the basis of a flight of stairs. I'll show you how to get the proportions of the stairs right compared to an average adult, and I'll show you how to draw the side view, the front view, and the oblique view, and I'll make some comments comparing upstairs versus downstairs. To understand stairs, you need to understand inclined planes. If we're at the base of these stairs looking up, then our eye level is low. The vanishing point for the buildings converges toward our eye level because we and the buildings are on the same level ground. The incline for the stairs converges toward a vanishing point vertically above the one for the buildings because they're connected, or at least angled in the same direction. The more these vanishing points are separated, the more dramatic the image and the steeper the hill. And this is easier to depict than a gentler slope like this walkway, which has a much smaller or shallower pitch, and so is difficult to see. The buildings have real horizontal and vertical lines unless they recede in the distance, in which case they converge toward the vanishing point. In this picture, the walls converge toward a vanishing point on eye level, since their base is on the same level ground as the viewer. The stairs are on an inclined plane, so their vanishing point is above eye level. Since these two structures are attached, the uphill vanishing point for the stairs is vertically above the vanishing point for the walls. Stairs need to be in proportion to the figure. The treads where we place our feet are 9 to 11 inches long, while a foot is usually about 8 to 12 inches long. Risers are 7 inches high, and the handrail is 35 inches high. It hits the adult around the top of his thigh, so he can hold on to the handrail with a little bend in his elbow. The usual flight of stairs forms about a 30 to 50 degree angle with the ground. The side view of stairs show true horizontal and vertical lines, and also the true angle, which here is 30 degrees. When looking straight ahead at a flight of stairs directly in front of us, we see the treads where our feet land and the risers, which are these gray rectangles. The treads are usually light in value because they receive overhead lighting, while the risers are usually darker since they're shielded from the light. We see less and less of the treads as they converge toward the vanishing point on eye level, and eye level is where the tread looks like a line. Risers are composed of true horizontal and vertical lines. Since they're parallel to the picture plane, they don't foreshorten as quickly as the treads. The only lines that recede in the distance are these diagonal lines. A flight of stairs going down is much simpler, but it's an unusual view. Here we're standing on top of the stairs looking down, making this a bird's eye view, and eye level is well beyond the picture here. The treads converge toward eye level. We see only the treads, which are light in value, so there's little value contrast. And that's what makes walking downstairs difficult sometimes, because we can't see where the next stair starts. The treads, as I said, converge toward eye level, so we only see these diagonals and the horizontal lines. But there are vertical lines here that go down and connect to the diagonals. This one goes down and connects to the diagonals. These four stairs foreshorten much more quickly than the upstairs flight I just showed you, because we only see the treads that recede in the distance. We don't see the risers. Pictures of stairs going down are unusual and often evoke emotions. These stairs suggest danger since they're twisted and seem very steep, especially this flight in the middle where the stairs are very close together. Walls can make stairs look dark and potentially contributing to the feeling of danger. I love this sign here. It says, "Please watch your step." and it actually looks like one giant step from here to here. The placement of horizontal lines for stairs going up or down can be determined using what I call multiplying rectangles. That is, connect the lower corner here with the middle of the next stair to find where the stair above it begins. This causes these lines to get closer together with distance, and it works mainly when we see only risers going up and only treads going down. This is a pretty easy way of drawing the front view of stairs going up. So you start with an isosceles triangle with two equal sides and identify a vanishing point above eye level. Then decide where you want the first riser to be and connect its corners to this vanishing point. Then at number 1, connect that to the vanishing point on eye level where the tread looks like a line. When this line crosses this lower black line, draw another riser vertically up, and when it hits this blue line, then draw the vanishing point, the line to the vanishing point. And where that line crosses this black line, draw another vertical. And when you get rid of your construction lines, then you have the vertical and you have the line going to eye level, the vanishing point on eye level, then you have another vertical, and then the line going to the vanishing point on eye level, and then your final vertical. On the side view, the stairs have true horizontal and vertical lines, and the treads and the risers all converge toward a vanishing point on eye level. However, the handrail and these inclines are all parallel, so they don't have any vanishing point. In contrast, for the oblique view, the treads converge toward a vanishing point on eye level since they're parallel to the ground, and the incline converges toward a vanishing point directly above this level vanishing point. My painting shows the side view of stairs and the frontal view. In the side view, the stairs are composed of true horizontal and vertical lines, and it has the true angle of about 30 degrees. The banister is parallel to the stairs or converges toward the same vanishing point. For the frontal view, I use multiplying rectangles to find the positions of the stairs going up. That is, I connected the lower left corner to the middle of the next stair to find where the stair above that begins. You could also draw stairs without a vanishing point by drawing a triangular prism. To do that, start with two right triangles. Then connect them with these diagonal lines to form the inclined plane. Then draw true horizontal and vertical lines and the diagonals from each, and duplicate the stairs in the back. You can use this approach to draw a symmetrical organic shape. For these flights of stairs, the railings converge toward a vanishing point on eye level, as does the broom. In this situation, the upstairs and downstairs flights converge toward vanishing points vertically above one another, and the vanishing point on eye level is from these railings converging toward it. For the stairs themselves, they converge toward different vanishing points on eye level, here and here. And if we look at this flight of stairs, again, we have two vanishing points for these stairs and this vanishing point for the other flight of stairs. In my next video, I'll discuss using the plan view, and please remember to subscribe.